Hello, guys, and welcome to our class for today. And today we'll be treating a very important topic, which is regression model. And regression model is a very important analysis and in the statistical world, and it spans to very different areas of statistics, even very forensic areas like big data, artificial intelligence, data science. All these areas use regression model, and also for very petty analysis like project analysis, research analysis. It's a very household analysis. So I really want us to catch this. If you can catch this, then you are already taking a very big step in your journey to become a data analyst, to become your own data analyst. Okay, we have different types of regression model. We have linear, logistic, polynomial, ridge, lasso, quantile, Bayesian linear regression. I don't just want to bore you with all others. I'm going to be dwelling on the most important and the most encountered regression model, which is the linear regression. I can assure you that throughout my journey in data analyst for years now, it's only once I've encountered a regression model aside linear regression. So, for the purpose of this course, we'll be treating linear regression, but don't worry, with what we'll be learning in linear regression, the rest follows the same principle. So what's linear regression? Linear regression is the most basic and commonly used type of regression model. It is a predictive analysis. The main idea is to investigate and postulate us. So linear regression basically does three things for us. Number one, it does a set of predictor slash independent variables do a good job in predicting an outcome slash dependent variable. Now this is the first time we're encountering this independent and dependent variables. So, but I'm going to explain more of that in a consequent slide. But the main idea, one of the very important things that linear regression helps us to do is to check if the independent variable can be used to predict the dependent variable. Remember earlier here we said that what it's a predictive analysis. So one thing that makes it very forensic and makes it need people to use it a lot is the fact that it can be used to predict your future. So it's a kind of predictive analysis, and when you are given a data set, you want to check if the independent variable can be used to predict the outcome or dependent variable. Don't worry if you don't understand what I'm saying, take that just take me by my word for now, and then subsequently you are going to understand exactly what I mean by that. Number two, which variable in particular are significant predictors of the outcome variable, and in what way do they indicate by the magnitude and sign of the beta estimate impact and outcome variable. These regression estimates are used to explain the relationship between one dependent variable and one or more independent variables. Now what this is just saying is that in the case where we have more than one variable, we can use the linear regression to, to indicate which of those variables affect the independent variable, and to also know the magnitude, indicate by the magnitude and by the sign of the beta estimate. Now, if the beta estimate is positive, it means something. I'm going to explain all that for you subsequently. But as I say, just take me by my word for now. It's used to basically investigate the kind of relationship or the kind of impact this one have on this one. So it doesn't just tell us if they are related, it is a good predictor. It also goes a step further to tell us the kind of impact this variable have on this variable. How will we know that? By our beta estimate. I'm going to explain what we mean by beta estimate and by the sign of that word, beta estimate. Number three, another important thing it does for us is that it generates an equation that can be used to predict the dependent variable. Now, after doing a linear regression, we are going to generate an equation that can be used to predict the future or to predict the dependent variable. So let's just jump into the next slide. Now, independent variable. Remember I said we're going to discuss independent variable. Independent variable is the condition that you change in an experiment. It is a variable that you control. It is called independent because it is the value because this value does not depend on and is not affected by the state of any other variable in the experiment. Sometimes you may hear this variable called the control variable because it is the one that is changed. Do not confuse it with a control variable, which is a variable that is purposely held constant so that it can't affect the outcome of the experiment. Now, what this is simply saying is that it is in an experiment a variable that you can easily change, that you can alter, or that you are in control of, and there is nothing else in that experiment that controls it, is our independent variable. While our dependent variable, on the other hand, is the one that depends on the other variables in an experiment. Let me just read what I have here. Dependent variable is a condition that you measure in an experiment. You are assessing how it responds to change in the independent variable. You can think of it as depending on the independent variable. Sometimes the dependent variable is called the responding variable. So as you can see, this one dependent, it depends on the independent variable. Now I just made an emphasis here. The control variable is not the same thing as control variable. Control variable are the ones you hold constant so it doesn't affect your experiment. Then the control variable is the one you alter so that you can see how it affects the dependent variable. Let's quickly look at an example to help you understand this. Example of dependent and independent variable. How long you sleep affects your test score. So now, what is our independent variable here is how long you sleep. That's the one we can easily change. Then how long you sleep is, does it affect our test score? So it's an independent variable, and in this experiment, test score is the dependent variable. So test score depends on how long you sleep. Number two example we have here is how much rainfall, independent variable, affects crop produce. So if, for instance, I want to check how much rainfall affects a crop. In that case, our rainfall is the independent variable, while our crop is the dependent. The crop performance depends on what? Rainfall. I hope we are getting the logic behind this. Or let me think of one more example. While back then in secondary school, I loved chemistry. So I remember that, although I later on studied statistics, but I remember that then he told us that pressure and temperature affects the speed of an experiment. So in that case, if we want to check the speed of an experiment, pressure and temperature will be our independent variable, while the speed of our experiment will be the dependent variable. I hope we got up to this point. So what are the two main types of linear regression? We have our simple linear regression, our multiple linear regression. So simple linear regression has only one independent variable, while multiple linear regression has multiple independent variables. For instance, in the earlier example when I said rainfall affects crop produce, if we're only using rainfall, that means we're talking about a simple linear regression. But if we're checking how rainfall, humidity, and sun affects crop produce, in that case we have three independent variables affecting one dependent variable, which is crop produce. So in that case, we are using a multiple linear regression. Remember that the idea of this course is not just to just show you how to do the experiment, it's to help you to understand when to use the experiment, how to use the experiment, and how to interpret the experiment. That is the whole idea of this course. So once in a while, I'll be chipping in some of all these things so you can understand when exactly to use which experiment. And let me just mention here, if you signed up for this course as a freelancer hoping to make money from this course, really pay attention to this, because I remember that the first cash I actually made from this was actually from data analysis, was actually in simple linear regression. It was from a colleague then in school, and when the project stuff started, she wanted to do an experiment, and she just felt she saw my results in the department and said, "This guy is good. Instead of giving all these guys the experiment, why not give this guy?" And she came, it was just a simple linear regression. She wanted to check how the money budgeted, how much will be budgeted to education in the next 4 years. Remember, I told you linear regression can be used to predict. So we just brought in how much Nigeria has been budgeting so far in education, and then we just use simple linear regression to get our equation and postulate it. And guess what? I just told her 20,000 naira, and she didn't argue with me. Those are the kind of clients I guess you will be praying for. But on a more serious note, it's a very important analysis. So, in the purpose of this course is to be your own data analyst, so you can learn how to do this thing yourself. And if you signed up as a freelancer, I can assure you you won't regret it. Okay, now equation of a simple linear regression. Remember, I told you that we can use this to predict. At the end of the day, we're going to form an equation that we will use to predict. So this y here is our predicted value. This b here, b naught. Remember when we talked about beta initially, where we say that we are going to estimate our beta, and our beta is going to tell us the kind of relationship that the dependent variable has with the independent variable. So we are going to get our b naught plus our b1 and our x. So generally what happens is that by the end of the experiment, by the time you run this analysis using any software, we're going to run this particular analysis in Excel, we're going to run it in SPSS, we're going to run it in R, and we're going to run it in Python. So by the time you run it for any of the software you're using and any other software you want to use, they are going to give you this beta naught, and the software is going to give you this beta 1 as an output. So if I have this beta naught and beta 1 and I have my x, and I put x here, then I can easily find my y. Is that okay? So you can use it to predict your y, and this beta naught and beta 1 will tell you the relationship that x have with y. So I'm trying my best to make sure that we all understand what I'm saying. If you are new into statistics, some of these things might be a bit strange for you, but please don't give up yet. I read a book which says if you can always quit, why quit now? Just hang on with me, and let's go into when we practically start doing some of all these things, they are going to make sense to you, I can assure you. And also, if you finish going through the video and there's still need for you to go back and watch it from the beginning, please do that. Then for multiple linear regression, in this case, we have x1, x2, up to xk. So if we are dealing with maybe 4 variables, it's going to be x1, x2, x3, and x4. So if you are doing multiple regression, you are not going to, your output is not just going to give you b0 and b1. In this case, it's going to give you b1, b2, b3, and b4. In the example I used earlier about sun, humidity, and rainfall, that means it's going to give us b1, b2, b3, and our b0. So with that, we can use it to predict our y. So for instance, if you have your b0, b1, b2, and b3, if you say, okay, if the rainfall is so centimeter square, I don't know, and the humidity is so, and the sunlight is so, I don't know what they use to measure those. So by the time you have maybe a value for x1, x2, x3, and you already have your b0, b1, b2, b3, by the time you do the calculation, it will give you a y, which will give you also output. So that's just basically how it works. So this is how the output looks like for Excel. So in this output, this is what we're looking for. This is our b0, and this is our b1. Is that okay? And this is what tells us whether it's significant or if it's not significant, if the regression model is significant, and this is what tells us whether this intercept is significant, this p-value here, and if this one is significant. Sorry, this is what tells us if the regression model is significant, not this. Sorry about that, not this. This is not what tells us whether it's significant. It's this that tells us whether it's significant. Um, we're still going to do the hands-on section, but this is by the time your output comes out, if this p-value is less than your alpha value, it means that whatever this beta give you, whatever of this beta is significant and it can be used to predict the outcome. And then this is our intercept here. If it's less than 0.05, which is mostly the conventional alpha value, whatever your alpha value is, it means that that intercept is significant. Alright, so in this case, if you notice, it's a simple linear regression. So we just have our beta naught and our beta 1. Let's look at how, okay, for this is multiple now. Are you seeing multiple? We have our intercept, then we have variable x1, x2, x3, and x4. So in this case, these are all the betas here, and these are all the p-values showing whether they are significant or whether they are not significant. And this one is telling us whether the whole overall model is significant or not. And then this is our SPSS output. So in SPSS output, this is for simple linear regression. So this is telling us whether the whole table is significant or not. And this one is giving us our beta value. This is standardized, this is unstandardized, and this one is for our intercept. So this is SPSS output for simple linear regression. So guys, I guess I'll stop the video here because it's getting long. Then in our next class, it's going to be strictly how to do it with software. By the time we do it with software, I'm going to generate the equations for you, and from there combine with what we have just done. Then I'm going to spend time to explain the interpretation for you, the basic things you need to know about the interpretation. Remember, for those of you who are not into statistics, I'm just going to show you how you can interpret for your research and you are good to go. And for those of you who are in statistics or you want to go into other statistics or data fields, then I'll still drop some extras so that you can make use of it. And I guess we're going to stop here.
Hello and welcome to the practical section of our linear regression. We had spent generous and ample time explaining the theoretical part, and that is actually should I call it the boring part now, but this is actually the much more interesting part. So let's go into the real stuff now. So let's understand our data set first of all. Here we have our aptitude test and we have our performance. Now this is a job scenario and in this, before they picked workers, they did an aptitude test for them, and this was their score all through the test. Then after the test, they they checked their performance at the job and discover their performance. So now I want to investigate. Okay, these are the employees' name. Look at the employee name here. So they now want to check whether their aptitude test number one can be used to predict job performance and what it's going to be the performance of somebody given that he performed so in his aptitude score. I don't know if you understand what I'm saying. I don't know whether I came out clear enough. But basically what they are trying to do is to find out if this aptitude test we run, whether it's a good test to check how workers' performance will be eventually when they get a job, and to also create a model that can help them predict how someone will perform depending on what he scored in his aptitude test. Remember, the first test is to check if this aptitude test is even a good test for checking performance, and number two, to be able to predict Okay, if somebody comes in randomly and now scores 40 tomorrow, what are we expecting the person to, how are we expecting the person to perform in the job when he eventually gets the job? Now, in this case, remember this is a simple linear regression because we just have one variable and one independent variable and one dependent variable. So in this case, what's going to be our independent variable? Our independent variable is going to be aptitude score. So our independent variable, which is our x, let me drag this downward. Our independent variable is going to be aptitude score, and our dependent variable is going to be performance. Now let's continue from here. So the next thing is, let's go into the recalculation now. Now there are 3 ways for doing this, but I'm going to show us 2 for now. In the course of this video, I'll be discussing 2. I'll be discussing the normal tab method. Remember when we're doing descriptive statistics, I discussed that we have our tab method, just the normal formula tab method for doing this. So let's go to our formulas. So this is supposed to be formula tab, not data tab. So under our formula tab, we need to get our B. We need to get our B1. We need to get our B1, and that B1 is our slope. And that B1 is our slope. So let's get our slope. So it's called slope in this one might not come handy. Remember when we're doing mean, when we're doing max, when we're doing mode, it was quite easy to predict what it's going to be like. But in this case, it might not necessarily come handy. So you have to I think maybe you can easily Google it out. In a case where you don't know the formula, you can easily Google out the formula, and definitely you're going to see it. So in this case, for linear regression, for this B1 here, it's called the slope. So what am I going to do? I'm going to go to more functions, statistical, and I'm now going to go down to slope. So this slope here is what's going to give us our B1. So I saying returns the slope of the linear regression through the given point. So this is definitely what we are looking for. So let's click on this. So now our known y, remember what's our y here? Our y here is performance. So I'm going to highlight this performance downward and click enter. Okay, sorry, I was supposed to have put my distance also. Let me start afresh. Okay, I'm supposed to have put my x also. I didn't put that, so let's start afresh. Statistical, let's go to slope. So from here I'm going to pick this and then go to my x. Let's pick our x. Our x is from here downward. So from here I'm going to click OK. So we have our slope here. So now let's pick our intercept. Our intercept is this B0. For those of us who have basic knowledge in mathematics, we will know that equation of a straight line is y equals to mx plus c. So that is exactly what we are trying to do now. So immediately we get this, we can get our regression line. So now I've gotten our slope. So remember, in our normal equation, this C here is our intercept. So the same thing goes here. So we're going to get our C here. So how do we get our C? So we're going to pick so from here we're going to pick our performance. So we're going to pick from our formula bar, we're going to go to statistical. We're going to go to intercept. Now this is it. So let's check. Calculate the point at which a line will intersect the y-axis by using the best fit regression line plotted through the known x values and y values. So this is what we're looking for. So our known y, these are known y, and our x now. Then I'm going to click OK. So from there now, our B1, we've gotten our B1 and we've gotten our B0. So in this case, if we want to write out our regression equation, what is it going to be? It's going to be 0.75, and then we will now have what? 7.9. So this is what we have as our regression equation using our formula tab. Now the bad thing about this one is that it doesn't tell us whether it's significant or not, whether the relationship is significant, whether we can trust this regression line and all that. But I just felt I should teach you this before we now go into the analysis toolpack. Personally, if you want to do any work on this, I would prefer you use this method. Sorry for that. I prefer you use this method. So let's go to our toolpack method. So we're going to go to data analysis toolpack. Now we're going to pick regression. This is regression, so I'm going to pick regression. Then I'm going to input my y. Remember, our y is performance, or let me pick plus the performance downward. Then our x range. Our x range is this downward. Let's just go with the default settings. Yes, our this thing have labels on the first row, and let's put our output range still on this sheet. So our output range should be here. This output range is just telling you where do you want your output to come out in. So let's put it here. Okay, whether we want standardized plot, normal probability plot, do we need this? Okay, let me just include this and let's see. Okay, so this is our output. So the first thing I want us to do is, first of all, let's make this bigger. Let's make sure that we can see everything. So we're going to go to home, we're going to go to format, and we're going to go to auto fit column width. So this is what we're going to have here. Now to get this, we'll need, so now that our output is ready, we'll need to now interpret what we have here. Now, I mentioned some of the basic interpretation in our former in our theoretical part, but let me just go through them again. Now, this is how our output will look like, whether it's Excel, whether it's SPSS. This is basically how it's going to look like. Now, our multiple R, what does our multiple R tells us? This is just a correlation between them. It's just telling us how related the first data and the second data are related. The maximum relationship is +1, and it can either be from -1 to +1. So if it's 0, there's no relationship. So from here we are seeing that it's about 83% relationship. In our next class, we're going to be doing correlation, so you're going to understand more about this first output here. Our R squared is basically telling us if we draw a regression line, for instance, after, remember that this thing is giving us the equation here is giving us a straight line, right? So by the time we draw that line and we plot this graph, how many of the points fall into that line? How many of these points, these random points, fall into the line that this regression line gave us? So that is going to be that's what we mean by R square. Then adjusted R means the same thing. So it's also called the adjusted R square is better for when you are doing multiple linear regression. So it's better you use that. This is your standard error and this is your observation. So let's go to the next table. In this our next table here, let me pick my draw tool so that we can know exactly what I'm talking about. So if we pick this significance level here, tells us the level of whether this regression line is significant or not. Now, the smaller this is, the better for you. So from here, it's obvious that this is significant. Now, this number you are seeing here is an exponential. It means 5.15602 times 10 raised to the power of -6. So that's about 0.00000051. You understand? So this is a very small number. Most times we test significance at 5%, that is 0.05, or 1%, that is 0.01, or 10%, that is 0.1. So this is obviously smaller than even 0.01. So that means our regression line is significant. What this table is telling us is that this is the most important thing in this table. All these ones are targeted toward getting this outcome. So what this one is telling us is that our ANOVA is what? Significant. It means that our regression line is significant. It means that we can trust our regression line. Now, formula tab will not give you that using that normal formula tab, but this our adding will give you that. So it's telling us that our regression line is significant. That's one. Now, the next thing now is, in that, if you check, the whole regression line is significant, but the regression line is made up of two main parameters, our B0 and our B1. Our B0 and our B1. So let's check, is this B0 significant and is this B1 significant? Now, this B1 is aptitude score, right? So we want to check if is this one significant. Now, if you notice, this coefficient is the same thing with what formula tab give us here, 0.790. That's the same thing that this one is giving us, 0.7534. 0.7534. So that is the same thing. So that is the limitation with formula tab. It only gives you that basic output, but there is more to it. As you can see, we are seeing other things that are very, very important. And as I said, if you are dealing with a real life situation, I would recommend you use this method, because it's in this method that most whether it's a research or whatever the case will be, that will add more value, or that will make what you are doing to make more sense. So the next thing is our intercept. Our intercept is this one here. That's the same thing we have here. So 7.902. So here we have 7.902. So this is where you get the things you use to create your equation. The next important thing here is our p-value. Now this p-value is telling us whether this thing is important or not. Are you seeing that whether this one is significant or not? That means, is it a good predictor? Are you seeing that here this is 0.05? So this is it's not a good predictor at alpha equals to 0.5, that is at 5% and at 1%, but it's significant at 10%. Why? Because it's less than 0.1, but it's not less than 0.5, so it's not significant at 0.5. So in most research, they'll tell you, they'll give you alpha. Please, if you don't understand what I'm saying about alpha, I'm going to create a short video to explain what I mean by alpha. But basically, or those who are new into this, those who have a statistical background will understand perfectly what I mean. But those who are new into statistics totally, most times when you are giving an analysis, they will give you an alpha. They will say, okay, at alpha equals to 0.05, or at alpha equals to 0.01, or at alpha equals to 0.1. What it just means is that this analysis, we want to be, if it's 0.1, that means we want to be 90% sure that whatever they are giving us is correct. If it's 95, that means we want to be 95% sure if it's 0.05. If it's 0.01, that means we want to be 99% sure that whatever you are giving us is correct. So depending on the analysis, but generally what is generally recommended is 0.05. But for some analysis, maybe medical analysis and the rest, they normally make it maybe 0.01 or make it smaller. Then for things that are not too significant, or they can go for 10%, but generally 0.05 is the standard measure. So thank God that this one actually just cuts through, so between the three of them. So this one for 0.05 is not significant, that is this, because it's greater than 0.05. For 0.01 is not significant, obviously, but for 0.1 this is significant. So it depends on the p-value for this analysis, but this one is significant irrespective of the analysis. You can see it's very, very small. So all these ones are just telling us the impact of each of these on the regression line. They are not too important, so I won't dwell on that, because this video is already getting very long. So but these are the basic things you need to know while creating your data set. So this is our normal probability plot. This is our normal probability plot. So this performance, and this is sample percentile. So normally I don't recommend plotting graphs using Excel. If you want to plot graph, maybe by the time we go into SPSS, we'll learn how to plot some of these graphs better. MCSS are better than Excel when it comes to graphing. So from here is the same thing. We can just pick up those values and replace it here, and we get our equation. And now, for instance, so this is where, so remember we said this is used for prediction. So let's say, for instance, somebody now gets let's say somebody scores, let me drop my pen too. So let's say somebody scores our X to be, somebody scores 36. Now what are we expecting the person to get by the time the person becomes a worker? What is the performance we expect? So what is it going to be? It's going to be equals to 0.75 times 36 plus 7.9, right? So remember our BODMAS rule, multiplication before addition. So it's going to multiply first, then plus this, so we're on the right track. So even if we don't put our bracket, it will still work perfectly well. So let's enter. So that means if somebody scored 36, the person is going to perform 35 in his job performance. We are predicting that his job performance is going to be 35. So that is basically it about this. This video is getting long, so I'm going to stop here. In the next video, I'm going to show how to do multiple regression. Then after multiple regression, I'm now going to show you how to report it in a real life situation. So in our next video, we're going to do how to create a multiple regression and then how to report our this thing. Now what I mean by report is, now we have known we understand it now, but now by the time you want to report it, maybe you are doing a research, or maybe an NGO, you are doing a research and want to report it to authorities. Now you will not cycle out these tables for them and explain it to them. There is a statistical way of writing out your answer in a way that makes sense, so that anybody who understands statistics, once the person sees it, just like a statistical language, the person will understand perfectly what you mean. So in our next class, we're going to learn how to report this data set. So in this class, we have learned our theoretical basis for regression line, and we have also learned our simple regression line using two methods, that is the formula tab and the analysis toolpack. So bye for now and see you in our next video.